Hello everyone, data structures, recursion. Let's see now how we can implement the code. You can open up your Eclipse program. Let's make a new Java project. We'll name it Recursion. Then we will create our package. Let's name it also Recursion. And also a class. We will name it, for example, factorial. Finish. And now we want a method which we will call, for example, iterative factorial. Public static, because we want to be able to call it inside the main method, and because it will return an integer. Iterative factorial, and we will take as parameter an integer n. Now we start by saying if the n that we give you is equal to 0, then I want you to return 1 because I'm done. And then we will say integer f equals 1. This is exactly what we stated in our slides. And then at the end we will return this f. But meanwhile, we just want to manipulate it. And we will say, we will create a for loop for integer I equals 1. And you will iterate so much until you reach the n, or number. And then I want you to increment your value by 1. And then what do we do here? We do f equals f multiplied by I. And this is something that you can write with another way in Java, like that. F multiplied equals I. This line is exactly the same as this line. You can write it like you want to, however you like, I meant. So now we're pretty much ready to test it. We will go here in our main method, and we will call this method iterative factorial here. And then we will say I want you to take as parameter the number 3. But remember, if we run it now, we will run a method which returns an integer. If we want to see something in our console, we need another method, the method systemoutPrintln. So now we will be able to see something in our console. Let's save it and run it. And as you can see, we take the result of 6. You can also try it with another number, the 4, and run it. And we take instantly a number 24, which is the correct result. So we know that our code works, but see how we wrote it. Let's see now another approach. I will create here another method, the recursive approach. For our recursive approach, we will create another method, public static again, recursive factorial. And as parameter, we will take a number n, exactly like before. Now, I forgot something. Integer. I want an integer to be returned. Now we will say again, if the n equals 0, then you can return 1. This is exactly the same thing that we wrote before. And then I will write the the following. You can return n multiplied by recursive factorial n minus 1. And this is it. Instead of writing this whole thing here, just write these 2 lines of code. But let's try it. We will copy this one. We will set an empty line between them, or we can say recursive approach. And then we will call our recursive factorial. And let's see with 4, because we have here the number 4. And let's run it. And as you can see, we have the same result. Let's make it cleaner. Iterative approach. So, as you can see, we have the same result. Let's calculate with 3. And again, the same result. Let's calculate with 5. As you can see, 4 was 24. 5 is 120. And if we put the number 6, then we have 720. So it increases itself rapidly. Let's try with 10. And the number is even higher. If you want to try it with 40, let's say 40, then I hope that you have a strong computer. And as you can see, we get a result of 0. So we say, doesn't our code work? It does work, but you need here to consider one thing. We used integer, and integer is not that great if you want to calculate huge numbers. So if you want to still be able to calculate it, you don't need an integer because the number is too huge. You need a double. So we put double, and then we can run our code, and as you can see, I take a huge result here. And the same would happen if I put double here, double, save and run it. The same number, the same huge number. This was the approach. You can also check our previous video with the theory, and you can compare the code with the theory and see and try to understand it.